Ladies and gentlemen, boys and girls, children of all ages, welcome back to another question. In these videos, I go over exam techniques, how to approach the question, and also the common mistakes that you can make while going over the questions. The questions that I choose are from mathsgenie.com, so if you would like to find similar questions, you can always go on MathGenie on the GCSE section and then find all these questions. Today's topic will be product rule for counting, and unlike my other videos, I will not be going over the last question that is available. So this question says, there are 30 students in a class. 2 students are going to be selected to receive a prize. How many different pairs of students could be selected? Now, the first thing we're going to do is we're going to go over the main parts of the question, try and understand what the question is asking, and then we'll get on to answering it. So firstly, there are 30 students in the class, and 2 students are going to be selected to receive a prize. The question asks how many different pairs of students could be selected. So those are the 3 important pieces of information from the question, and now we can get on to answering the question. I think to be able to answer this question, we'd have to simplify it a bit. So let's think about 5 people. Imagine there were only 5 people in the classroom. All right. And if 2 students were going to be selected to receive a prize, how many different pairs of students could be selected? Well, let's have a look. The possible pairs could be student 1 with student 2, student 1 with student 3, 1 with 4, or 1 with 5. And those are all the combinations possible if student 1 was one of the winners. Now, if student 2 was one of the winners, then we could have student 2 paired up with 1, 3, 4, and 5. For the number 3, it would be 1, 2, 4, and 5. You can probably see where this is going. Person 4, it'd be 1, 2, 3, and 5. And for the 5th person, his pairs could be 1, 2, 3, and 4. All right, and just to make it easier to look at the numbers, what I'm going to do is I'm going to change the colors of the pairs. So you can see who the second person is. All right, so over here we can see that there are altogether 4 by 5, so that's 20 pairs that are possible. However, the question does say how many different pairs of students could be selected. What that means is, in this case, when we have student 1 and 2 being paired up, that would be the same pair as student 2 and 1 being paired up. And therefore, they're not different pairs of students, so we would have to not double count them. So what we can do is we can remove all the numbers that appear twice. So we already have 1 and 2 here, so we don't need 2 and 1. 1 and 3 is already here, so we can't have 3 and 1. 1 and 4 is here, so we can't have 4 and 1. 1 and 5 is here, so we can't have 5 and 1. If you go on to the next column, 2 and 3 is the same as 3 and 2. 2 and 4 is the same as 4 and 2. 2 and 5 is the same as 5 and 2. The next column we have 3 and 4, which is the same as 4 and 3, 3, 5, which is the same as 5 and 3, and finally we have 4 and 5, which is the same as 5 and 4. So we are now left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we started off with 20. So we started off with 20 pairs. But because the question is asking us for different pairs of students, we ended up with 10 pairs. Now what you can probably see here is that the number of pairs has halved. And that is because every single pair appeared twice. So we'd have to halve the number of pairs. So the question would be answered by saying there were 10 pairs of students. All right. Now, keeping this in mind, we can now perform the same task with 30 students. So if there were 30 students, I'm not going to rewrite down every single student because that would make a lot of columns and a lot of rows. But from our previous question, we can see how many rows and columns we would have. So the number of rows was 1 less than the total number. So we know there'd be 29 rows. And that is because each student can only be paired with 29 other students because they can't be paired with themselves. And secondly, we have 5 columns, which is the same as the number of students. So beforehand we did 4 times 5 to give us the total number of pairs possible. Over here we're going to do 29 times 30 to give us the total numbers of pairs possible. And that would give us 870 pairs. Now that's how many total pairs there are possible. However, we have to take into account that every single pair will be counted twice. So, to find out all the number of different pairs, we will have to divide our answer by 2. Once we do that, we should get 435. And that would be our answer. There are 435 different pairs possible. Hopefully this has shed some light on to how to answer this question. If you have any questions, please do leave it in the comment section below, and I will see you in the next video. Okay, stay safe.